Given a function, we're going to determine the intercepts, rate of change, and the domain and range. The function that we're looking at is f of x is equal to 4x minus 3. Another way to write that function would be y equals 4x minus 3. So I'm going to first determine the intercepts. If I was going to find the x-intercept, the first thing I would do is set y equal to 0, and then substitute that value in and solve for x. So 0 would be equal to 4x minus 3. So 4x would be equal to positive 3. And our x-intercept would be 3/4, or 0.75. Our y-intercept we would do by setting x equal to 0. So we have y equal 4 times 0 minus 3. So y would be equal to negative 3. So for our x-intercept, we have coordinates 0.75 and 0. And for our y-intercept, we have coordinates 0 and negative 3. So now I'll take these and put them over on my graph. So here's a graph. Now I'm going to be careful with the scale on this one. I'm going to go 1, 2. Actually, no, I'll make that a little bit different there. Let's go 1, 2, 3, negative 1, negative 2, negative 3. So I have a y-intercept of negative 3, and my x-intercept was negative 3/4. Actually, let me change that scale again. I meant to do it this way. Let's put 1 here. So 3/4 would be right here. So now I have 2 points, which is enough information for me to create my line of my graph. And I can extend that line then as long as they're passing through my 2 points. Extend it this way a little bit as well. Okay. So this graph now will help us get the rate of change, and also it will help us to get the domain and range. So let's look at the rate of change now for this. The rate of change is the change in the dependent variable over the change in the independent variable. So we're looking at what's happening vertically with our graph and horizontally between any 2 given points. So if I wanted to look at the rate of change between this point and this point, the intercepts, I notice that vertically I'm going up 3 units, and horizontally I'm going to the right 0.75 units. So the rate of change in this case would be positive 3 divided by 0.75, which when simplified actually simplifies to 4. So 4 over 1, or just 4. And you can see here, if we look at our graph, just get a different color here. If I start at any point on our graph and I go up 4 units, so if I started here and I went up 1, 2, 3, 4, and I went over 1 unit, I'd have a point. And that pattern would continue. So there's our rate of change. Looking at the domain and range of this graph, we can see here that for the domain, we can actually have all values, all real numbers. So we would say that domain is x, such that x belongs to a real number system. And the range are all y values here. So y such that y belongs to a real number system.